Hey guys, welcome back. In this video we're going to be covering static routing. Some learning that we need to do before we can accomplish this is about what's called a routing table. Each router will have a routing table, and essentially in order to forward packets, a router must know how to reach the destination, meaning it must have a route in the routing table. The distance to that destination, known as the AD or administrative distance, as well as which path to take to get to that destination. In other words, which interface it needs to send the packets out of, or which neighboring router IP address it needs to send the packets to. The router will select the best path for traffic based on its AD, which lower is going to equal better. New command for this lesson is IP route, followed by the destination network, a subnet mask, and either the exit interface to leave the router or the next hop IP or the IP address of the connected router. This will create a static route to another network. One thing I want to cover that I forgot to mention in previous videos is that a default gateway is essentially your way to exit your local network and traverse the internet. So you've noticed when we've gone into the computers in other labs, we give them an IP address and a subnet mask as well as a default gateway. And that default gateway is usually the IP address of the router that is connected to our part of the network. Essentially, that's just a way so our computer, if it is trying to send a packet to someone that's not in our network, it says, I'll send it to the default gateway, and that guy is going to know how to get this packet to where it needs to go. So with that said, we can go ahead and come down here and hop into our lab. Purpose of the lab is to configure static routes between the networks and then ping across them or ensure that there's connectivity. So if we look over here at our tasks, task number 1 is to configure in-use router ports with IP addresses that correspond with the networks that they are in. Alright, so each of our routers is going to have 3 ports in use, and we can see in this diagram that there's a network down here, up here, and then there's a network in between each router. So remember, routers divide networks. So let's go ahead and start by hopping into router 0. Go into our command line interface. Go ahead and enable to get to privileged exec mode and then configure terminal to get into global configuration mode. Then let's start hopping into these interfaces and giving them IP addresses. Let's start with interface G000, IP add, and that network on G00 is going to be this 50.50.50.0/30. So we'll go 50.50.50. We'll give it an IP address of .1, and that mask is going to be 255.255.255.252. And we'll go ahead and issue the no shut command on that interface to bring it up. Hop over to interface G001, give that an IP address of 10.10.10.1, and that's 255.255.255.0. No shut to bring that one up. Last, let's hop into interface G002, IP address of 60.60.60.1 with that subnet mask 255.255.255.252. Corresponds with the /30 in that network over here. Go ahead and no shut that one. Okay, so that's that router. Let's go and do that with the other 2 routers now. Go ahead and get into global configuration mode. Start with interface G000 here. This is that 60 network, so we'll go IP add 60.60.60.2 because we gave 1 to the other router. 255.255.255.252. No shut. We see that link come up on our display on the left. Go into interface G001, IP add 20.20.20.1, 255.255.255.0. No shut. We see our local network comes up for that router. Hop into our interface G002, IP add 40.40.40. We'll go ahead and give this one 2. 255.255.255.252. That corresponds to the /30. No shut on that. Alright, so all 3 interfaces are configured on that router. Let's hop into our final router. get into global configuration mode, hop into interface G002 to start. Go ahead and give it an IP address of 40.40.40.1 because we gave .2 to the router 2. 255.255.255.252. No shut. We see that link pop up in our diagram. Hop into interface G000. Give it an IP address of 50.50.50.2 because the other router has .1. 255.255.255.252 for that subnet mask. No shut to bring it up. And that link pops up. Finally, our internal interface G001, IP add 30.30.30.1, 255.255.255.0, no shut, and our internal side pops up. Okay, so that should be good for task number 1. We've just set IP addresses on each of the 3 interfaces that these routers all have. Now, task 2 says configure IPs on the computers that correspond with the networks they're in. Okay, so down here in the 10.10.10 network, let's give this computer, go ahead and go 10.10.10.3 for him, 255.255.255.0. Give him that default gateway that we gave the router interface, which was 10.10.10.1. Call that good. Hop into PC0. He'll be in this 20 network, so 20.20.20.3 sounds good. 255.255.255.0. His default gateway is that router interface, which was 20.20.20.1. Lastly, hop down into our PC2. Give him an IP address in the 30 network, 30.30.30.3. 255.255.255.0 corresponds to /24. And his default gateway was 30.30.30.1, which is that router interface that connects to that network. That looks good. Next, step 3, ping within each individual network to ensure LAN connectivity. So let's go ahead and ping our default gateway from each computer, and that'll ensure that we have full connectivity from the computer all the way to the router. So in this one, hop into its command prompt, ping 30.30.30.1. We can talk to him. Hop over to this computer up here. We'll go ahead and ping 20.20.20.1. We can talk to him. That's good. This computer, go ahead and ping 10.10.10.1. And we can talk to him. So within each of our local area networks, we have full connectivity all the way to the router. That's good. Step 4, verify that there is no connectivity between PCs in different networks. Okay, so if I was on PC2, I shouldn't be able to ping PC0, which would be 20.20.20.3. And that is correct. See, it says destination host unreachable. That's the router telling us, hey, I don't know how to get there, so I can't send this packet anywhere. Move on to step 5, configure static routes on each router for the 3 networks that are not directly connected. So if you look at each router, it's got 3 networks connected. This one would be 30, 40, and 50. And 3 networks not connected, like 10, 60, and 20. Let's go ahead and start with router 1. What we'll do is we'll go into global configuration mode, and we'll say IP route. We'll go ahead and say to get to network 10.10.10.0, 255.255.255.0, I want you to go out my G000 interface. That's telling him if you want to get to this network, exit this interface and head that way. Then we'll go ahead and give him a route to the 60 network, IP route 60.60.60.0, 255.255.255.252. Go ahead and go out that same G00 interface. And then to get to the 20 network, IP route 20.20.20.0, 255.255.255.0. Go ahead and exit our G002 interface. And then if we go ahead and exit out of here and do show IP route, we can see in his routing table, now he knows where all 6 networks are and how to send traffic to them. Let's do the same thing for the other 2 routers really quickly. So in here, go ahead and IP route to 30.30.30.0. Send him out G000. IP route to 40.40.40.0.
G0. Send him out G000. And then IP route to 202020 0. Send him out G002. And if we go ahead and do show IP route, we can see router 0 now knows how to get to all 6 networks in the diagram. Final router, go IP route 303030. We'll go ahead and do this one different, and we'll choose the next router's IP address. So router 1's IP address on this connected interface, which I believe we gave an IP address of 404040.1. And we'll go IP route to 505050. We'll send him the same place as the last traffic, 404041. And then IP route to get to the 101010.0. We'll send him to router 0's closest interface, which I believe was 606061. And I actually believe I messed this command up because that's the wrong subnet mask for that 50 network. So what we can do is we can use our no command, do no IP route 505050, and then we can retype it. Should be good. So if we go ahead and show IP route, we can see now that this router knows how to get to all 6 networks in the diagram. Perfect. Okay, so last step, verify that now we have connectivity between the networks. So if we hop back into this computer, to the command prompt, we run that same ping command to hit computer PC0. We should be able to reach it now because our router has a route to that network, and that router has a route back to us. If we go ahead and hit PC1 at 10.10.10.3, same thing should happen because we gave our router a route to that network, and we gave their router a route back to us. And there we go. So in a nutshell, guys, that was how you can configure some static routes on your network. You saw how tedious that was, and that's why there are better ways to do this. There's something called dynamic routing, which we'll get into in later videos, which essentially allows your routers to share information betwixt them about the routes that they can see so that you don't have to enter every single route manually. But I hope you enjoyed this video. I hope that it helped you learn a little more about routers and routing, and we'll see you in the next video.